Here we have question number 9.1. Question says an object of size 3.0 centimeter is placed 14 centimeter in front of a concave lens that you can see in the diagram. Focal length 21 centimeter. Describe the image produced by the lens. What happens if the object is moved further away from the lens? Right. So this is the question. Before starting the question, I want to make you clear about the theories that are involved in ray optics. Like you can see here that there are only these theories that are currently in ray optics, and that you have to only revise, and you can solve each and every question in this exercise, right? And your that question coming in your board. So first of all, you can see that there is concept like basic concept, then mirror formula, then reflection of light, then total internal reflection, prism, optical instrument, and then lens. And this particular concept is from lens. The question that is asked is from lens concept. Here we have used the lens formula, that is 1 by v minus 1 by is equal to 1 by f, and with time you can also revise this, that is similar, little bit similar, just to that minus is plus, right? So that way you have to revise also with while you are studying, and that will keep your data or the concept retained in your mind, right? So now let's come to the question and let's solve this. So as you know that the question is we have read this, and that I have also drawn here. Your V is 8.4 that I have calculated, that you have to calculate, right? The given thing is 14 centimeter distance of object and 21 centimeter the focus of this concave lens, right? So we know the focus always lie in the negative of the concave lens, right? And the distance that this side, right side, is taken positive because the incident ray is in this moving in this side, right? Simple. The direction is clear, right? Now let's try to solve this. So first of all, you have to write the given that, and in given that we have the object height that is given in question, that is in positive, means above the principal axis, right? And the object distance is u is equal to minus 14 centimeter. That means key the 14 centimeter of the object distance is from 14 centimeter from the pole, but in negative direction. Then focal length minus 21 centimeter in the negative direction from the pole, right? Then you have to just put that, after getting that value, just put that in the lens formula, and you will get, by calculating it, simple calculation, you will get the value of V, that is image distance, and that is also you are going to be negative. That means the image is also going to lie in the negative side or in the left side of the lens, right, at 8.4 centimeter. Simple. Now use the magnification to know the behavior of the image, that is m is equal to v by u, and that is h dash by h also, that is image height by object height, and that you can calculate m is plus 0.6. Plus means your the image the image that is going to be here, like erect, virtual and erect, and if it is minus then real and diminished, right? Simple. And if the magnitude is less than 1, that means it is diminished, and it is greater than 1, that means it is magnified, right? Simple. And that I have written after that you don't have to take bother about it. Then you have to multiply h dash, that is image height, to get image height in that you can get from h into m, that is going to be 1.8 centimeter, that is the image height. So the image that is going to form here is in the positive, so it is in positive, so in the positive direction of like above the principal axis, right? So it is like this, and the height of this image is going to be 1.8 centimeter, 1.8 centimeter, right? Simple. And after that, what is there is you can write that nature of the image explicitly here. So the image distance is positive, that means image form in the front of the lens. Simple. Magnification is positive, that means image is virtual and erect, right? Simple. And then magnification is less than 1, that means it is diminished. Simple. And hence the image is virtual, erect and diminished. Simple. And one thing also that is asked in the question that you can see is how that image is going to change when effect of moving the object further away. So while you move that image further away from the lens, the image approaches to focus and become smaller. So you can also write that the image the image will become approach to focus and become smaller as you take the object away from the lens, right? So approach the focus and become smaller. So if we take that image away, then the image will try to move toward focus and the image size will decrease, right? Simple. So it is a simple question. You just have to know the sign convention, how to use it, and they put into the formula, and then how to use the sign convention here. What is the meaning of the sign convention in magnification, and what is the meaning of magnitude if it is less than 1 or greater than 1? Simple. That is the basic theory that you have to keep in mind. And this is the your solution that you can see. Okay.